model. So that's the difference. Now, what I'm talking about, if you actually had the ground measured in a full way, that would be different. If you actually had a certain level of assumption based on models, based on the sky in those two positions, to then fit into a model. So that's the difference. Now, what I'm talking about, if you actually had the ground measured in a full way, that would be different if you actually had that. But that's the thing. The globe, you're going off the globe model, which has already been, like I said, I think it's already been
What was his statement? Could I ask a question? You're saying that your official location doesn't match the sky, then I would say that the official location is more than likely wrong. They're giving you a false data set. Like, okay, you actually live here, when in reality, in relation to the sky, that's your true fix. That's your true position. Whatever they're telling you, if it doesn't jive, is the false answer.
And I mean, Ruhif, I'm fine to say that there's no. We should let you go. We've been talking a bunch of. Well, let me just say my last thing. I mean, I just. So I already laid out like what would be needed to do this with a planar stationary surface. Like I already, well, I laid out the one thing, but I mean, also, in order to do this, like you would have to have basically the right map in the distances in order to do this.
Yes.
Yeah. So the fact that a stationary planar Earth at this time in history doesn't have that is a thing. I have no problem. It's not like a concession, but I'm saying like I understand that's not a thing that exists right now. Yeah, that's fine, but that doesn't mean that a false one or one that's based on assumptions is somehow better.
You need the right map to do celestial navigation.
Yeah, and you're assuming you have the right map. That's the thing. You're going off.
This is what you said. Okay. You need the right map.
Well, you need the coordinates. You need to understand. You need to know where the GPs are, and you need to know the distances between those GPs at the least.
Yeah, the distance. And yes, we share the GPs, all right? Because that's just where the star is overhead. But the distance between 2 points, that's where the difference is, right? We know the distance between 2 points.
Yeah, that's why I'm saying. That's why I was saying, like, where are you really? That's why I was using that wording, like, where are you really? Because yeah, like, are you X miles apart? Are you, the exact mileage? Now you're going off an assumption based on information you're given, which is why I said folks that are doing these star fixes, this is a very crude way to put it, but it's like they're going on the internet, getting information, looking at the sky, or getting information off the internet, as it were, in terms of all this that we're talking about, and then looking at a star and then fixing it on that model that you were originally given. So, I mean, again, that's not impressive. I understand from your perspective, you might think, well, it's the right model, so I have it right. I get it. You can think you're right or do what you need to do. But the thing is you don't actually have that. So really, you don't have it either. You have something that was given to you and an image of the sky. So, yeah, you're right. I guess it is kind of like superior right now in this argument, maybe, because you could say that, like, even though your model's assumption is something you don't have verified. So in a way, neither of us have it. You don't either.
So you're backtracking on you need the right map to do SolNav.
We're getting to we're trying to get to the truth in all of this.
Wait a minute. You're saying that I got the conversation halfway. Is he saying that his position in Australia doesn't match the sky position?
It's about getting a star fix. It's about getting a fix. And the Globe guys claim, which they can because of the way it works. You can get a fix right now if you went on the internet. If you could do the whole thing. You could get a fix. So he's talking about getting a fix, and you can do that at least somewhat accurately within like the local city regions, like I said, Sydney, New York, wherever. And with a stationary planar Earth, I don't know that anyone has that currently, because you'd have to have, I'm not saying you'd have to have the entire map, but you would definitely have to have the distances and GPs independent, not even using any nautical almanac or any of that stuff that's given to you, independent. Although that's a question, are those even contested? I'm not necessarily claiming those are contested, but nonetheless, that's a whole another layer of it all. But I'm just saying, if you were to go out, you could get your GPs yourself and then map with your circles of equal altitude and so on, to where then if somebody came to you after you've done that, let's say you did that, if somebody came to you and said, hey, I want a star fix, you could do that. You could do it in an instant. But the Globe claims they already have that. That's the thing. The Globe claims they have it, and there it is, the Globe. So
does anyone here use the almanac? Has anyone in here? Does anyone own an almanac, a nautical almanac? Because I was thinking, what if there's two? What if there's one north of the equator and one for south, or is it just one book? Because I've never actually opened one.
There's just one.
No, you
It's
can
online.
download it. Just go to Almanac 1913 or some shit. You'll
It's
get
a
it.
complete map of the world. Then anywhere in the world, it should be like legit. It
just
should
tells,
work.
It tells you where the stars will be at any time. Yeah, that's it.
It gives you
I wonder,
GP.
Gio, do you think?
Okay, Roof, I got a
do you
question
think-
for you. You said you need an accurate map. What map are you
No,
talking
Geo
about?
said that. Geo said you need the right map to do celestial navigation, and I 100,000 trillion% agree.
Well, you need distances.
Yeah,
I mean,
which
you know,
map that Roof are you referring to? I mean,
yeah, I
What
mean, you
map
don't
do
need like
have?
you don't need like the shapes necessarily of every rock in the ocean or whatever, like or in every little outcropping. Like
Oh,
I'm not.
no,
I mean, yeah,
no.
a full map would be amazing and all that, but yeah, you definitely need like information that you are just pulling off basically the internet from authorities. And I know you believe them, or you think it's true or whatever, but that kind of means you don't have anything. No offense.
You know what's
just
funny?
To
The
go
right
off
map.
some shit, just to go off some other shit. Yeah.
Hang on, the
Yeah,
right
so
map
basically what
means
you're asking
knowing
for
the
is-
distance between 2 points.
Yeah, at the same time, it sounds like you think that we should make up a new set of GP of stars.
Another question for you, Roofy.
No, hold on.
No,
You don't,
you said
hold on.
you-
He just said that. Wait, well, are you gonna shift to something else? Well, hold on.
No.
Let me just say real quick to that. I'm not.
Yeah, Gio, that's how I understood you. That you think we need to redo GPs of stars.
No, I'm not necessarily saying that. I said in my thing there, like, I mean, whether the nautical almanac is contested or not, like I said, that's a whole nother can of worms. There are, perspectives that that came from an actual plane data set to begin with. The actual nautical almanac itself. We could get into all that, but I'm not necessarily claiming that you would have to do that. But if you really want to do it independently and not depend on any other sources in that way, then you would, yeah.
Yeah, okay. It's a hell of a job, though, but it can be done. Yeah.
We have the GPs. That's already done.
Yep. And confirmed over and over and over again.
Okay, what's the problem with that then?
Yet you're still here.
No,
The key is the distance
no.
between 2 points.
Yeah, the sky's a
When
dome.
Geo says you
The
need
earth,
the
the
map.
earth, the earth ain't a dome. You're taking the dome in the sky and you're transposing it to the ground, and you're saying it's correct. I'm pretty sure that's actually what's going on. That's got to be the prime oppositional argument, at least. I can't actually prove that that's what's going on, but
Okay. The key
So,
to having
like,
the right map.
You guys
is
don't have a
knowing-
problem with the stars being like in the same relative position to each other year after year. Like you don't. There's no expansion of the stars. They're not getting further apart.
they're too far away.
Oh,
We're in
there's
the
a
same
tiny-
galaxy,
We know the
dude.
arguments.
Yeah, we're in the same
They got
galaxy.
dark matter and some other
Right,
whirly
anyway.
stuff going on, okay? But the
What?
stars are where they are.
Well, it's another topic, too, though. But Ruud, did you have a response to it? Were you gonna say something? Respond to
doesn't
that?
matter.
Well, it's like we went a bunch. You didn't have your. All right, I thought you had a response.
So Ruhif, if I take the stars in the sky and I domify them, right, rather than saying that they're sort of basically flat, which is what you guys kind of do, and then you impose. I think this is what you guys do. You impose that upon the ground, right? If the sky is curved, then it
I
would
don't know what it
you could do a
means to say the sky is
transpositional
curved.
data. Pardon?
I don't know what it means to say the sky is curved. All right, when
You
I
don't know what it
when I talk
means to
about
say that
Altaz,
the sky is curved.
yeah, when I talk about the celestial sphere, I'm talking about a direction pointing system, not an actual shape.
So the sky is flat, and that's how you treat it, and then you transpose it down onto the ground.
The sky, there are stars fucking trillions of miles away. I don't
Yeah.
know what it means to say it's flat. The stars
Do you not
out in
recognize
space
that
are no
you-
way.
If you take it two parallel planes, right, and then dot different points across it, right, and then you start rotating them around, you can perform ratio transpositional data that would allow you to basically from any position on those two curved surfaces that you're manipulating, depending on the way that you work with the optics, but you could actually make it appear to look flat just through the mathematics and calculations. So the thing is, I actually don't know whether or not you guys recognize that the sky actually could be the curvature, and you're just transposing it down onto the ground. And at that point, this is the mathematics that sort of occurs. It's the
If
The
I have a
observation
GP
becoming a material reality in your imagination, though.
If I have a GP that I have to draw, I have a GP on the ground, and I need to draw a circle on the ground with a certain radius. That has nothing to do with the sky.
There is a proportional relationship between the ground and the sky. I agree with that.
I didn't mention the sky. I said we're on the ground. There's a spot on the ground, and I want the points that are 1,000 miles away from that point in a circle. That has nothing to do with the sky.
Yeah, but dude, when
How
you're
are you
relating
measuring
when
that?
you're relating two positions, it absolutely does. If you have your New York and Sydney or whatever you said you and Bacon or he's in South America. So yeah, when you get two, then now it does matter the sky, the shape of the
No, it
sky.
doesn't. No, it doesn't.
Yes, it does.
What
If
is
you have
between
the
two over the
You
ground?
can't point. You can't directly see them, dude. You're
Yeah,
using the sky for like proportional relationship to their position in the sky. That's how you're actually denoting your position on the ground. This is why
Let's say there are
Old Mate
no
could find
stars.
you. He
There
could
are
find
no
your
stars. The
house.
stars all disappeared. What is the distance between 2 points on the
How
ground of the
closely
Earth?
did he find your house? Just out of curiosity, was it within 100 meters? Within 1 meter?
Yeah,
What?
about 50 meters. Yeah.
50 meters. I mean, that's pretty impressive. I'll give you that. Like, I didn't know you could actually do that. So, like, tip of the hat. It doesn't sort of dismiss the notion, though, that you could actually do it. Like, if you're working with transpositional data points and like working on, I don't know how you guys do this exactly, but yeah, I could definitely see that you could, through the mathematics, transpose the sky, which is curved, into the ground, and then claim that the ground is curved. Because, like, I mean, this is basically relativity. You don't even know whether or not the car's hitting the tree or the tree's hitting the car. Like, did the
For
planes
the
hit the buildings or did the buildings hit the plane? Who knows
For the-
these days, right?
for the fifth time, let's say all the stars magically disappeared. The question is, I have a spot on the ground. What is the distance between point A and point B? Nothing to do with the sky. Absolutely nothing.
How do you test, like, how do you go on the ground without the sky? We black out the sky for a moment. How are you knowing that you've got 1,000 meters? Oh, sorry, what was the distance you specified?
If I the formula you use to give you the points on a circle around a given point tells you what shape of the Earth, what tells you what the shape of the Earth is. Right? So if I use have a sign, I am saying the Earth is a globe. If I use some, triangle based like law of cosines kind of thing to work out distances on an AE map, right? Then I'm using the AE map. So
Dude,
when
if you've got two
celestial
positions on the
measure,
ground, what are you measuring in respect to the two positions on the ground that you cannot measure directly? Put like point A and point B on the ground. Point A and point B cannot see themselves.
right?
Is that where you're at? Like,
We're
explain it
talking
from
about
there if you can.
drawing circles on a map. All right. So we have the center of the circle. And we have a distance. Right. So depending on how you like the coordinates of those 360 points around that circle, how you come to those coordinates tells you what the shape of the Earth is. Right. So if I draw 3 circles and they intersect at a point, that tells me that the method works, and this method does not work on any other shape of Earth.
What does the angle of those 3 points add up to? Like, if you're 3 points, triangle, what do they add up to?
If I had 3 points on the Earth on a sphere, and I was able to draw a big triangle, they're more than 180
If it
degrees.
was a sphere, it would be this. That's like immediately where your mind goes to. But all I asked
Because
you is actually,
we
if you're
don't measure
claiming that
those
you know
angles.
the distance between those 3 points, then you must know the angle, right?
No,
But then you're saying that if it's a
don't know the
sphere, it
angle.
must be greater than 180 degrees. Is that what you were going to say?
Because we don't measure those 3 points, right? These are 3 GPs. No one ever has
Okay.
measured the angle between those 3 points.
I don't know where we're at anymore, man. Like, you got 3 points on the ground. I don't understand how they're interacting with one another. How are you
Right.
measuring between the points?
Yeah, we're not measuring, right? We're drawing a circle on a map.
So you're
And
doing a
if
Venn diagram? Okay.
yes, yes, actually we are. Yes, we are.
Yeah,
Um,
I
and
appreciate that. Yeah,
those three
triangles are
circles
very
will
powerful.
intersect. Those three circles will intersect, or they won't. All right, they only intersect on a globe. They don't intersect on
Okay,
any
this is
other
just
shape.
circular reasoning now, Roofy. You've got to back off a little bit, mate.
All right, shut up, you commie fuck.
I I I missed the last sort of jump there that you're doing. So what was the like relationship between what you're saying, the 3 points on the ground? What was the relationship you're pointing at?
You draw a circle of equal altitude on a map around each point with a given radius.
Uh-huh.
Right?
Uh-huh.
Those three circles, they don't intersect on a flat Earth map. They do intersect on a globe. That's how you get your position fix, and that's why it doesn't work on a flat Earth.
You're doing some pretty complex geometry with my imagination at the moment, so excuse me if I sort of I need a couple of pictures or something. But I don't want to get
Menu
buried
for
down in this unless someone else wants to jump in the conversation, right?
But Riksy, if this
share Google
if this
Earth.
particular concept is news to you, how are you slightly earlier on, able to make assertions about how this is an illusion from the curved sky to the flat ground?
Well, clearly, I mean, maybe Ruhif's got it explaining something that I'm familiar with, but in a different way. I've got no idea at the moment. Whatever he's sort of articulating at the moment, I'm not able to encapsulate. So, excuse me for quote unquote lack of understanding or something, Pazza.
Can you see my screen?
Oh, that's very legitimate to be intellectually honest. So that's very refreshing, and I appreciate. That's always positive to just be honest about your. Yeah,
It is.
So
Yeah.
I'm not saying I'm not saying he doesn't know anything. I'm just asking. I very worried personally about making assertions from. I just haven't got a clue, or I haven't got some of the contingent aspects of it
No.
down in my head.
Well, I would like Roofy to demonstrate this experiment where him and Bacon worked all this out. This is like amazing.
Yeah, but Pazza, to be fair, there is a difference between a discussion versus a debate, and maybe Ruhif and I were a little bit more debatey, and then maybe, you know what I'm saying?
Yeah.
Like, because if someone's debating, then it's like, yeah, you would hope that like they have the on par information to keep rebutting every point up and up, you know what I mean? But these conversations sometimes, flow in various ways. So yeah, it's not.
I get it. My parlance isn't without fault.
Yeah, pretty boilerplate, pretty cut and
God
dried.
damn it! I haven't heard this one. Maybe I haven't gone into it.
I mean, I'm joking, but I mean,
Oh, okay.
well, I mean, I'm
Dude,
not
I've-
joking. That
I've-
is pretty
I've-
standard stuff that is being talked about. Yeah, I mean, in
Can
terms
you
of
see
this.
my screen, Rick?
I'm looking at your screen.
Cool. That is a circle of equal altitude. So everywhere on that circle has the same angle of elevation to the star.
Look at those.
Okay. Yep. Cool.
So the question is, what would that Roofy? What would that look like if you say put that on an AE map or a flat surface?
Oh, what would that
Where all those
circle
lines
look
go?
like? Not a circle.
Yeah.
It would look
Where would all those lines go? Would they all converge on a single point, or would they all
Wait up.
be
All over
parallel?
the
Or?
If you brought those stars closer to the Earth, would that affect the nature of the
Yes.
proposition?
Absolutely, that is the
Yeah.
first
I've
thing that
already
they
broken
do
it
with their.
apart, man. I haven't even I'm already seeing the fucking the symmetry bullshit they're pulling. This is
Yeah,
hilarious.
Hang on.
69 degrees per
Why is that?
miles per
But you
degree.
just said if there was some aspect of the universe which was radically different, would this work? And we said yes. And you said, "Aha! I can see through the bullshit." Well, it does work, and it does reflect a conceptualized notion of where these things being so far away that these lines of sight are effectively, and also to all intents and purposes, parallel. But why, when you say if they were nearer, would this be the same? We say no. How do you think this is a gotcha?
Well, hold on, because it would be different. So if you have, let's say you put all the stars really close, like the thing of like corpuscular rays kind of thing, the corpuscular ray effect, which I know that's a whole nother discussion. We get into all that, but I'm just saying that like just a much closer angles. So if you took all those stars and brought them all close, you're gonna have like basically like V's coming off the stars. You know what I mean? You're gonna have these angles, kind of like the corpuscular rays, that are going to completely change that if you then keep it on a curved surface. So it does change them. The only way that this works in this modeling is if you put the stars really, 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 really far away, the light years and that whole thing, to where now the light is hitting the Earth, quote unquote, parallel, which invokes the planar geometry. That parallelity, if that's a word, the parallelness of that, is parallelity a word? It should be.
That would
Parallelism.
make sense. That would make sense, Geo. Yeah, but if you do those positions on the ground there onto a flat map, and you do draw the lines off the surface, don't go to one single thing. I think they flail all over the place.
Well,
They're
that's
not
a claim.
You lose the 69 miles per degree. That relationship doesn't have any justification then.
It's not just a claim. It's demonstrated. Have you not seen Joss Lay's videos where he simultaneously shows line of sight to the sun at various times of year across the entire surface? And he rolls it using animation from a globe to an AE map.
Someone posted it 17 minutes ago.
Yeah, it was just the one that, and actually the one Terry posted does sort of show that the geometric transformation. I mean, dude, to put it really simply, the sky is curved, the ground is flat. That's it. That's really the whole effing thing. Whatever the sky is, it has that spherical geometry in its motion and in its positioning. Why that is, what it all is, we could get into all that. And of course, the globe does claim the sky is like a celestial sphere that goes around the ball. So in a way, that's the same. But at the end of the day, that's it. You know, folks on the globe are saying, well, the globe's curved. The sky is also curved, but it's really, really, really far away. Therefore, it invokes a different geometry when you put them light years away versus close, which is what Riksky said.
Well, it invokes the geometry. It makes a proposition that these things are a long, long way away, and it runs through the ramifications of that geometrically. So my question is, why doesn't someone propose how far away Polaris is, show it on a flat map, and let's run through the ramifications of that from a geometric perspective?
Oh, I know what's going to happen, Pazza.
Well, we could do that, or we could talk about what happens when you die, because those are.
Well,
anything to push it beyond now.
Where would you like to? Let's start. Where would you like to propose the distance to Polaris is, and let's see how that would plan out in terms of how we see it from around the realm we live on.
Well, I'm not really getting into that because I don't have any way to tangibly, physically verify that. We can calculate that through angles and get a calculation. You can get a calculated altitude. I'm just referring to the actual spherical geometry of how the sky, looks and moves and functions on that level. That's why I was saying, like, the sky is curved, ground flat, and in terms of the base of the geometries of how this has been, how these geometries overlap in some ways.
The vast majority. Oh, sorry.
So you would need individual films for each individual viewer, and they would all be different.
I mean, we can all make claims day in, day out, man. And if you guys claim that the stars are like infinity away, I mean, it does cause a sort of impact upon the modeling that you're going to perceive. But you can't measure that. Just as we can't get to Polaris, these notions of these measurements of the stars that you're referring to is it's a pretty extreme claim to say that you can actually go do that, man. Like, I'm pretty reserved in what I sort of claim is true.
And Paz, if you want to semi roast me, I know you were going to go next, but if you're going to semi roast for not having the altitude of the star, well, do you know how far away the stars are? How many light years?
No, I wasn't going to do that, Gio. But what I'm saying is that there is a relationship between the sky and the stars and the Earth and its surface that is proposed in the conventional scientific, the conventional realm in which we live. It's spherical and there's things at distance. Okay, yeah. Now, as that happens, that all correlates up as being shown. Yeah, if the angles work, the angles you see would be the angles that you would get if you're on a sphere looking in the relevant directions. And also we've done that with the final experiment. The angles to the sun are such that there's a bit that's continuously lit light one end and lit the other, and that none of this breaks down, or none of the observations we make on a day-to-day basis of the sky, anything in the sky, breaks down the globe model. It simply doesn't. That's why astronomy is just foundational in that respect, and it's purposeful, and as Rue Hips told you, it's utilizable. It has predictive capabilities. Now that's fine, and it still may not be the representative of reality in any way. But if you're going to propose a slightly different reality and say the sky's curved and the ground is flat, right? Let's nominally describe what we think about the sky. Where are these things? Let's propose distances and let's see if it all plumbs in.
You can perform what is it? You coming in like Stefan? Look, you can perform transpositional data sets in vast scales. Like, this is what I quite don't get about this argument, man. It's like none of this really actually discerns the difference between like the curvature of the Earth or the curvature of the sky. We've got to
Yes, it does.
find actually. I think I'd like to have the discussion about like what it could possibly be that we agree upon as far as a measurement that would discern the difference, because the transpositional data metrics, man.
What does
I've
that
played
mean?
around with a lot.
Transpositional data metrics.
I've played around with a little bit of mapping software and all the rest of it. I can see that I can map things across surfaces using the like basically the computational data like inset points. It's not too difficult. So and given the fact that the curve, right, is so small, which is what Rufi was bringing up before, you actually don't have to like the complex between flat and curved is actually not that much. Like as far as like what we can physically read, it is not that much. Hence the nature of the conversation.
If everybody sees Polaris, if there's a relationship moving as you traverse the surface northwards from the North Pole, when there's Polaris in the Polaris at GP, and the distance you move south is linearly proportional to the drop in elevation of Polaris. That has very significant ramifications on the shape of the Earth.
And then
If you
you
think that
incur
Polaris,
refraction, and to
if you
explain
think
the
that, well,
curvature at that point.
okay, so if you want to invoke a refraction to counter the fact that trigonometrically there's not a linear relationship, then what you're saying is that whatever we look at anywhere in the sky isn't where it is at all.
Yes, that's literally in the globe model as well.
No, it's
Everything
not.
is in an
No.
apparent position. As soon as it goes from your zenith point, your perpendicular, it becomes in an apparent position because out there is a vacuum. We just got done with
Yeah.
refraction and like what was the coefficient index of whatever, right? We understand that there's a proportional relationship between the mediums. We
Riksky,
all agree upon this.
When you look at a star, say at an elevation of 45 degrees on a clear night from where you are, there is a range of apparent to its position based upon a nominal amount of atmospheric refraction.
It's 1 arc minute at 45 degrees.
It's tiny. When you're talking about moving from the GP of a star in any direction, or typically Polaris, because it's one that stays where it is over a period of night to all intents and purposes, that linearity becomes so profoundly deviant from what we see that if you're going to invoke refraction, you end up with light bending in such a way is that you can't really make any meaningful construct in the sky.
And yet you guys think that what is it? You can see over the curve. I can see further than the distance of what would be naturally acceptable within the globe, like over the curve. And then when the refraction's right, it lifts that image up, and I can see 50, 100 kilometers from the ground all of a sudden.
Astronomers don't casually observe stars across the horizon. They don't do it at sea level, at 4 feet off the sea. The only time astronomers ever endeavour to spot stars at the horizon is when they're using them to corroborate refractive effects across the atmosphere, because they know where it would be. Because the whole topology of stars above you when you look up at night, as the night transpires and the whole lot rotates, the angular topology and the spatial topology of all those stars remains consistent.
No one's disputing the GP positions of stars in the sky, but in the relational proportion to the ground. I don't think that discussion's happening.
So
no one's disputing that.
Unless you think those stars are orchestrating some movement behind the scenes, so that through some refractive mechanism that you want to invoke, they all look like they're in the same place.
Okay.
I'm saying
it's not necessarily happening on a curved surface. It could even actually be a flat surface, but then because you perceive the world in a sort of a dome of vision,
the thing is like you say, arguably Occam's razor, first tenet of astronomy, when you look up at something in the night sky, it's roughly where it should be. No one's thinking that when I look north and I see Polaris, that Polaris is in fact 180 degrees behind me. That's not how
I didn't say that.
No, I'm just saying that one of the fundamentals of astronomy, with mitigating circumstances, things like atmospheric refraction, which is now understood and measured, is that by and large, the apparency and the actuality of something in the night sky is many meaningful sense in which we use in celestial navigation. Same.
Well, tip of the hat, you know more about this stuff than I do. I mean, I'm really outside of my realms of anything I've really dabbled in.
Once you do it,
But the sky, like the middle of the bowl is low, and as a like to hold the water on the inside, the outside becomes a bigger scale. But the sky stays in proportion.
To do in the
Did
north,
anyone
you
get what you
turn
were saying?
clockwise to follow it.
I got no
In
idea
the
what you're
south,
saying.
you turn anti-clockwise to follow the circuit of the sun. Two different points of rotation.
Yes,
of the sun.
okay, we've explained that, right? If you put a
Well, go
stick
on, how do you
in some
explain it?
water. Oh, jeez. Okay, can I?
You just said you're turning
I'll have a little crack
anti-clockwise
at it,
to
right?
follow the
Okay.
sun, and I'm turning clockwise.
Yeah, dude, if you take a look at the image, yeah, this is just very remedial. I don't know if you're trolling or if you're real right now, or being genuine or not, but it's kind of hard to tell. You kind of shift in and out of that.
Is that
But
your model
anyway,
of flat Earth? Is that what you're saying? That electric field of circuit, is that your model of flat Earth?
more trolling. I never even said that, dude. You're a very disingenuous
But it's
interlocutor.
got to apply to the flat Earth, hasn't it? It has to apply.
Nobody
so,
mentioned.
if you're this as an
Forget it,
explanation.
dude. Forget this. Moving on.
Could I ask? I mean, if you observe the sun then from the equator, it's sort of it's directly above the equator all the time. So how does this figure eight kind of thing? How should that look like from the
All right.
equator?
Well, yeah, I'll pick up and say my point, but I mean, Elderbear is playing games. He's interrupting now, and he's just trolling and trying to talk about flat Earth models, which nobody mentioned. So he's just like pre-trolling. I don't know. It's what it is. So yeah, I'll just say my point, which is I just posted that image. It has nothing to do with any models or anything. That is on the left an electric field circuit. On the right, it's a ferrocell, which is ferrofluid that is magnetized. Therefore, you can see the actual flux lines of the magnetic field. And you see what occurs there. You have 2 points of rotation, and you have one that's clockwise, one that's counterclockwise. If you see this animated, you'll see how that is. It's like like I said, dragging a paddle through water, and it creates the vortex and the anti-vortex on either side. And so when you have the 2 points of rotation, as it were, when the sun is in the north, it would be rotating around that one. This is basically by the way, this is a stereographic projection of a sphere, is what this ultimately is. So if you look at this here, see that's what that on the kind of vertical wall there, that's a stereographic projection of a sphere. So again, the sky being spherical doesn't mean that it is a sphere surrounding a globe Earth. It can have this stereographic projection of a sphere on a flat surface. But what you get with that is you get the 2 rotations. You get the North Pole as it's projected onto that flat surface, and you get the South Pole, and then you get the equator, which is a line in the middle, but that's all projected onto a flat surface. So yes, I mean, this could be part of a larger model, but I wasn't just posting it to say this is a flat Earth model or anything. I was posting it, we're talking about the stars and the clockwise and counterclockwise rotation and the equator line. And so the sun would be in one part of that for many months of the year. It would keep making those circles get closer and closer to the equator, go straight at the equator, and then it transitions into the south and makes that rotation. So it's not a figure eight in one go. It's 2 rotations that over the whole year you could say make an 8, like just like you could draw an 8 in there. But yeah, it's just those 2 points.
I really like this stuff because this is like a really simple sort of way of showing that what a 3-dimensional subject can be sort of projected upon a 2-dimensional surface. And as I said before, I mean, like, I am really willing to sort of tango with the notion that there's some sort of dimensional change that occurs that is disproportional to the ground and the sky. Whether the sky be curved or, as I said before, like maybe something scales up in the southern hemisphere that we just don't understand yet. But it would start like sort of explaining all these kind of peculiar phenomenons. Like, the reason for the argument, right, is because like we're at the limits of our capacity, like human capacity to explain this stuff. And I don't know, I'm happy with this. The fact that for anyone to say that you actually know is just peculiar to me.
So how far off could the sun be then to make this sort of figure eight movement?
You mean like the analemma?
No. Like Geo was talking about. How that ends up sort of circling in like a figure eight.
Sorry, what was the question? Because I was posting something. By the way,
I'm just wondering. I mean, to have this figure eight kind of thing, I suppose the sun must have a sort of a specific distance above this flat Earth to match up with the angles that we measure where the GP is.
I'm not sure what the thrust is, but look, there is definitely a proportional relationship between the ground and the sky. It's just that something is occurring is a differential. And it doesn't need to necessarily mean that it's globe or flat. Like, you guys are willing to accept sort of black holes and interdimensional space-time, but then when it starts coming to this stuff, it's like, ooh, no, it's a bit wary. Don't want to dabble in that stuff. Like, as far as an idea to explore, it's the same.
It's physics. There's physics that tells us about black holes. So I don't see why that should be a problem.
Yes,
even the most casual observations of the moon and the sun and the stars aren't contingent on us absorbing or even religiously accepting the fringe theoretical physics like black holes and.
Yeah, but you'll accept dark matter every day of the week. But
no, I don't.
We don't know what. Yeah, no, you don't. We don't know what it is. We don't know why it's looking like that.
You can't hold together your materialistic worldview as a consequence. You cannot hold together your materialistic worldview if you don't accept dark matter. Period.
No, it's not true. I mean, in the 18th century, when they still thought the Earth was a globe, they still had celestial navigation, they still had the almanac, and they still thought that it all worked and the sky was the way it was, and they had no notion or no concept of dark matter. It all worked.
You don't know what those people thought, Pazzaman. You just told them
they thought well enough of the globe as a curve and the celestial realm being the way it is at started distance to have an almanac and to use it and corroborate it and not die by running aground or starting at the feet.
You're on dodgy ground. You know you are. You're on dodgy ground with your bloody dark matter.
You can't claim like we are that this dark matter holds everything together for you, right? In your materialistic worldview, right? You've got to acknowledge that that's at the extent of your worldview. And then someone's talking interdimensional stuff, which you got your bloody black holes that mess with time space.
Interdimensional. What do you mean by interdimensional stuff?
So what, a black hole is not some sort of interdimensional sort of aspect of the world that sort of defies the nature of physics itself? Yeah, sure, singularity.
Yeah, yes, you get past the event horizon. Yes, our physics breaks down. That's true.
The event horizon. Do you ever wonder why they call it the event horizon? Like, and the horizon in that?
Yeah, the Scott horizon. Yes, I think I sort of remember why they call it that.
Yeah, beyond your limits of capacity to actually perceive. They refer to your horizon of vision, and they apply it in the field of like psychology. The event horizon.
See, this has got nothing to do with the fact that a lot of people believe there's a globe. They believe that the stars are at distance in a realm around us that goes under our feet and around the other side. That an almanac exists. Observing these stars as it's presented in that model, it works, it's corroboratable, and is measurable.
You can take a rendered proportional rational like worldview and say you measure it, but if you're dealing within the aspect of relativity, whether the sky's moving or the ground's moving, you guys can't tell. So
in what situation do we actually need to use relativity for observing the sky, how things move?
Explains everything beyond your event horizon. So you think you understand what the stars are, and then all of a sudden you got relativity.
So you're claiming science has no idea what stars are?
You're thinking you're looking up at those stars in the sky and you're looking at them millions and millions of years ago. They probably exploded by now. This is just the remnants of the light that's been produced down to you. Yeah. So you like this whole cosmos of yours could actually be completely black because they're so like an infinitesimal distance away. Like they're so like they're so far away, man.
No. Yeah, but how long does a standard G star or like a star like the sun last? Quite a few billion years.
I've been around for about 37 years. Okay, this is my existence. I assume that there's been a lot of stuff that happened before me, and there'll be a bunch of stuff that happens after me. But I wouldn't presume to know how long the stuff is going to happen, but like that of which happened before me. That's an instantiation. Like I don't know how you guys rationalize that.
Well, we can see the remains of the supernova, which was observed by the Chinese in 1061.
Is that the one that took out all the electrics or something? Like, are you guys worried about solar
in
storm?
year
In
1016. In the year 1016, the Chinese astronomers observed a supernova.
Okay.
And today, with modern technology and telescopes, they find the nebula, the rest, or they see what's left of that supernova.
Have you ever heard of like
Oh, yes,
multiple
yes. So
supernovas?
astronomy do know things happen
Yeah, but
in
Stefan,
space.
have you ever heard of like a place, right? Like, so a supernova occurs, right? It explodes. You would kind of like think that the explosions occurred and it just coalesces and it just chills out. But there's supernovas that regularly occur in the sky. I think it happened about 6 months ago from now. But that was like a once in an 80-year event. And a new star was born in the sky that wasn't there before. And that was a supernova. But the thing is
No,
that the
a new
supernova
star
keeps
is not a
happening
supernova.
every 80 years. Every 80 years, that supernova just keeps supernovaing. So what
No,
is it about
that's a binary. That's a binary system. Which
Are
one
you just going to
star?
assume it's a
I
binary
think
system and
that's a
solve the problem?
it's a neutron star orbits with
You're in sci-fi
a
land.
different other star, and they're so close together that the neutron star ends up making like a accretion disk of mass from the other star, and then when that builds up enough, I don't remember exact details, but then it's sort of, I
This
think
is
is it
sci-fi.
called
This is
a
sci-fi.
K nova or something like that?
This is sci-fi, man. This is
Why?
all
Why?
sci-fi stuff. Why?
Why?
Because I just mentioned before that you can't explain the movement of the galaxies and their lack of matter before. Like there's 93% or something of the matter missing to explain that, and then all of a sudden you think you've got an explanation of like nova happening in the
Yeah.
sky. You don't know
Yeah.
what 93% of it's doing. It doesn't make
No,
sense
but we
to
know what.
actually claim all
Yeah,
these
but it
things
does.
at that point.
Yeah, but they
You
have
just
a
know that there's a
very
lighter
good
to it.
idea. They have a very good idea what the stars are made of and the different types of star and how they
No, you
act.
don't. You've got one star that you've analyzed to like concur that, right? The so-called
Is
sun. And
that so?
I'll just for the sake of argumentation, I'll give you your whatever that, what is it, electroscopic technique that you guys import to say that it's made of hydrogen, whatever.
Spectroscopy, yeah, that's one thing.
Spectroscopy, yeah, that one.
Yeah, and then you have the electromagnetic spectrum coming from the sun.
Well, you just meant like you're measuring electricity in the sky. Cool.
No, and the electromagnetic spectrum, all the way from long wave radio waves all the way to, I'm not sure if there's much gamma ray coming from the sun, though. I don't think there are any gamma rays, but at least X rays. So the whole of the spectrum of electromagnetic radiation is coming out from the sun. Even neutrinos.
93 million miles away.
Yeah,
got it.
Yeah. No, it doesn't matter what the distance is. That's what has been measured and is measured. And if you compare that to nuclear reactions, you see how that is possible that this electromagnetic spectrum can be created.
Yeah, cool. You got explanations for stuff. Doesn't mean you actually know it. It really doesn't.
But let me ask you this then: do we measure a wide spectrum of electromagnetic radiation coming from the sun?
Dude, I'm all down for the notion that there's like electricity coming from the sky. All down for
It's
it.
not electricity. It's not electromagnetic, like light, X-rays, radio waves, infrared light, UVA, UVB, and so on and so forth. It's not electricity. Okay? It's not electricity.
There is definitely electricity coming from the sky. What's a solar panel doing?
Photoelectric. That is light.
Okay. If I take a copper wire,
they are using photons to create electricity.
if I put a copper wire up into the sky, do you think that I detect a voltage potential differential?
Yeah, there is in the atmosphere. Yes, there is. But
Right, so there's
that's
electricity coming from the sky. That's all I was wanting to say, bro.
But solar panel does not work by the electric charge in the atmosphere. It's by sunlight. It's by photons.
Yeah, I get the principle of perhaps a poor jump through on my part, but when I was referring to the electricity coming from the sky, like I just referred to the solar panels briefly, but I kind of was really like sort of thinking about the notion that you can put a copper wire in the sky and find a voltage differential.
Yeah, that changes a lot as well. In fact, it has been measured to vary between 30 to 600 volts during the year.
Nice.
It changes quite a lot.
Free
have
electricity.
Have you heard about the Carnegie curve?
Not specifically. Outline it for me.
Carnegie curve is basically how they measure how the electric charge in the atmosphere changes during the day or during 24 hours. And then you have annual measurements as well. And it varies from position to position on Earth as well.
Does it measure it on the ground or in the sky, or like?
You measure the charge of the atmosphere.
Are the satellites measuring it?
No, on the ground. Done from the ground.
They measure the sky, the voltage from underground.
Yeah, just look up Carnegie curve, and you can start off reading there. Well, sorry, got to go. Things to do. Friday. Yeah. Have a nice weekend, boys.
Good luck, sir.
Take care.
Safe travels.